Okay, we're on to another example. This is an example where, in some examples, setting it up in different ways, one is easier than the other. And this is a particular example where one way is turns out to be literally impossible by hand. You can only approximate it with computer if you do it by hand in one way, but it's just simple U substitution the other way. So again, I'm going to highlight my, I find the volume of the solid bounded by f of x y equals e to the negative x squared, and the planes z equals 0, y equals 0, y equals x, z equals 1. Okay, so you want to figure out like which one's going to be your height, which one's going to be your base. So my height is going to be determined by this function and the floor, z equals 0. Whereas my region is going to be determined by y equals 0, y equals x, and x equals 1. Okay. So let's draw the region. So y equals x, and then x equals 1, and y equals 0. So then that is this region right here. Okay? So I could do kind of vertical stripes or horizontal stripes. Okay? So this is, it's good to name like my three sides of this triangle. Y equals x is that side. Y equals 0 is that side. X equals 1 is that side. So if I want to do vertical stripes, then my y's are going between y equals 0 and y equals x. So then that'd be the inside is 0 to x, and the outside is the domain of those vertical stripes is from 0 to 1. Okay, and then e to the negative x squared minus 0 is just itself, and then I'm doing dy first and then dx. The other one, if I did horizontal stripes, then I'm going between x equals y and x equals 1. So my inner integral is from x equals y to x equals 1, and then from y equals 0 to 1. The domain of that is of those, the domain of those horizontal stripes is from x is 0 to x equals 1. Okay, the same function, e, poorly drawn, e to the negative x squared dy dx. Well, in this case, no, that's not right, dx dy. In this case, this integral right here is literally impossible to do by hand. There's no way to do it by hand. You can't even try. I'll just let you know it's impossible. You could do it, you could approximate it with a computer, but I mean, that doesn't help us here. Whereas this one, the integral, the inside integral is just a dy. There are no y's in here, so you treat the inside like a constant, and you get y e to the negative x squared from 0 to x when the dx is on the outside. Plugging in the 0 gives me nothing, so I might as well just plug in the x. I get x e to the negative x squared dx. And now I do have something I can integrate because I have u substitution. So if u equals negative x squared, then du equals negative 2x dx. And so then this is equal to negative 1/2 integral from stuff to stuff of e to the u du. So then that's equal to negative 1/2 stuff to stuff of e to the u. And so that's equal to negative 1/2 integral e to the u is e to the negative x squared from 0 to 1. And so then move that up here. It's equal to negative 1/2 times plugging in 1 gives me e to the negative 1. Plugging in 0 gives me e to the 0, which is just 1. So this equals 1/2 minus 1 over 2e. And that's it.